Yeah, I would like to know a bit more about cabri in physics. Like you can put physics parameters like weather, temperature, time. You can do graphics, all that with cabri. Can you talk about that a bit?
I have to say that the current cabri is not specifically oriented to deal with parameters, explicit parameters from physics like temperature or things like that. Yeah. But if you think about those parameters simply as values that vary from one value to another value or in interval or things like that, you can model, you can build models of physics phenomena. And what people using cabri in physics, they simply build a model. They're using geometric tools. They build the model, and then they can make the model directly working on the screen. With cabri, you can build a model and make the model working. For instance, if I take a simple example, the simple modelization of the light rays in a lens. You can easily, because in that case it's very easily construct the direction of the rays after they pass through the lens using the standard geometrical optical rules, and then you can move the object and see how the image is moving, or you can change how do you say this, the foci of the lens and see what's happening, changing the lens from a convergent lens to a divergent lens, and look at and for instance, to rediscover the so-called Gaussian position where the object is equal in size with its image, simply by dragging and making the model working. So this is one way. Another situation is could be also where you perform things that you normally cannot perform other way because it would be too complex to make the computation. Suppose you make a capacitor of a capacitor is made, an electrical capacitor is made of two plates with electrical particles on the two plates.
Yes.
But in cabri we will simply put 10 or a relatively small number of charges and geometrically computes the resulting vector of all the action of those particles on all those charges on one given particles, and then you will, by dragging the particle from outside the capacitor within the capacitor, rediscover that the capacitor phenomenon, that actually the field, the electrical field is constant inside of the capacitor and almost zero outside of the capacitor. Something that is very difficult to understand because you are told that it is so, and you have to believe this. If you build with cabri the situation, really putting a given number of charges on two plates, compute within cabri the vector, the direction and the size of the vector produced by each charges, add all those vectors together, you obtain the resulting field, and then you simply drag and discover or rediscover the capacitor phenomenon. Things like that.
Okay. Talking about modeling, I was told that you gave a conference about modeling a rainbow in cabri. Mm-hmm. Can you tell me something about that?
That's the same typically the same kind of situation. So the rainbow is it took time for the humankind to understand what was the reason for a rainbow to appear in the sky. I think it's at the time of Descartes, or somehow at Descartes' time, that people finally understood that this was a question of refraction and reflection inside of water drops that are in the clouds. And But if you perform the computation or try to think about this phenomenon in a standard algebraic terms, it's really complex to understand, and it's quite magic that finally you can show that the rainbow that the phenomenon of the rainbow will exist. If you do this in cabri, you will simply model a drop of rain by a small circle, and construct geometrically the refracted
the colors,
and you discover that there is a concentration of light rays in direction that comes simply in dragging. You see the origin of the phenomenon, and you understand deeply the reason you have this concentration of red that are in one direction in red, in the next direction in yellow and green, etc.
Yes,
so
all the colors.
In the colors of the rainbow.
Okay.
The idea is really to let cabri perform the computation for you. You simply construct the things as they are happening in the real world, and then let simply you do not have to compute analytically yourself, because the system, the geometry itself will provide you with a result.
Okay. Another question. Can you tell me about cabri around the world? Is the same? The people feel the same about the software everywhere, or there are some difference?
No, there is. This is interesting, and this is so from a cultural perspective. I think it's interesting. There is a tendency to think that about math or science that's the same everywhere. Somehow it's probably true, but somehow it's also not so true. And I will simply take a very simple example. When we started the cabri in France, the cabri was strongly influenced by the way we think in France at geometry, in terms of geometry being made of figures that are essentially abstract figures, not having any measurement in it. We are not interested in our culture about geometry in France in thinking that we have a triangle that has a length of 3 and 4.5 and an angle of 62 degrees exactly. And when we wanted to, at the very beginning, in the end of the 90s, when we wanted cabri to be used in Germany,
yes,
the teachers in Germany, they said, "Oh, this software is absolutely cannot be used at all, because we cannot measure things.
Okay.
We need really to have a possibility to have the exact value of the angles, the exact value of the side of the triangle, of the length of an altitude, and things like that." And if cabri today has quite an emphasis of measurement, and I think it's important to have the possibility, especially because of physics, to have the possibility to measure things. This is clearly an influence of the way people think about geometry in Germany versus the way we think about geometry in our country, in France. It's interesting because both countries, Germany is in France, and France are so close.
Yes,
you could think that it will be the same, but no. Somewhere it's really different.
Okay, is that because of the culture, educational culture of each country that causes that? Or why do you think there are those differences between Germany and France?
I think it reflects a very long history where it's well known that in the French culture we have been more interested in building theories, somehow not really empirical, not really based on data, but just more a construction of the intellect. And simply to speak about Germany, in Germany it's clear that their culture has been more influenced by engineer, where the question of measurement plays a very important role. And when I'm saying this, I'm not favoring one approach versus one other approach. I simply consider that it's really interesting to see the richness that comes from different. But between France and Germany, I think the difference started in the Middle Age, so it's not a new thing.
Yeah. Okay. And in other country, have you find